Hello. So I continue with the comments about assignment 7. I now added a part B to our problem 1. We now would like to find the perimeter of the triangle. So that means we are trying to find how much is x8 plus x plus y, so the sum of the length of the sides. We may be tempted to write the approximations of the values that we found for x and y and sum them to 8, and that's it. We'll see how this is not precise. So let's try this. So we'll be saying 8 plus 5.40, and here you know this is not a result, exact result, it's an approximation, plus 9.65, and again this is just an approximation. So if you do this in your calculator, you will get that the result is 23.5, which approximated to three significant figures gives us 23.1 meters. Okay, so our reasoning here is correct. We're just adding the length of the sides of the triangle. But our problem is that we are using approximation. So if we want to be precise, and I hope you do want to be precise, what we need to sum over here is 8 plus, and when we found x, we found that actually the value of x is 8 over tangent of 56. So that's what I'm going to write over here, 8 over tangent of 56 plus, and for y we found that the exact value is 8 divided by sine of 56. So 8 divided by sine of 56. So let's do this in the calculator. It's over here. 8, sorry, that's not what I meant to write. 8 plus 8 divided by tangent of 56 plus 8 divided by sine of 56. And here we have our result. Let's write it down over here, 23, here, sorry, 23.04, and then I don't know what it comes, which will be approximately 23.0, since the 4 doesn't change the 0 that comes before. So this result is not the same that we got before, but this one, 23.0, is more precise because here we're using exact values. And that's what you should be doing. If you need to approximate, on the last step of finding something. For instance, on the last step of finding the value of the side x. But if later on you need to use the side x, then you come here and you use the exact value that we got over there, so that our result is not affected by our approximations.